Yeah, so good evening. Hello, everyone. Nice to have you all back to our blockchain online meetup. It's the first blockchain online meetup in the new year. And we have a new topic for this, really promising and really visionary topic. It's all about machine learning and artificial intelligence on a blockchain platform. For that, we have two speakers from Fetch.ai. It's Emma Smith, it's the team lead of collective learning. And also we have Maria Minaricova, she's the director of business development, also from Fetch.ai. And for our second part, for the discussion, we will also have like one of our blockLAB association members, Ricky Lamberti. So this topic is everything about Fetch.ai, about the role of artificial intelligence, about machine learning in the blockchain platform, but also like a short introduction to collective learning. So let's have a look at our schedule. Short introduction about what is Blockchain Stuttgart Meetup and who are we. Then Maria will give you a short introduction to Fetch, so you know who is behind that. And also we will hear a keynote by Emma. And afterwards, we will step directly into the discussion with our speakers and with Ricky Lamberti and also with you guys. You can also be interactive and ask your questions. Just write them through or during the keynote into the chat group. I will have a look at it. And yeah, right now I see also a question. Yes, the session will be recorded and will be uploaded on YouTube. I will send all the links about blockLAB and our YouTube stream later in the chat. And after we had our discussion, we will try a new networking session on Wonder.me. It's the first time we will try that in the meetup session. Let's have a look. I'm also curious and excited to see. And just like a few more information and upcoming events, there is one event did happen. It was about the DeFi Jetzt. It's a German from a German partner from us. Also, like I will send you the links later into the chat. And also in 4 weeks, as every 4 weeks, we will have our next blockchain meetup will be about the metaverse, the kind of new buzzword of the year. And then afterwards, in 4 weeks, we'll have another blockchain online meetup, which is the topic set. It's all about digital identities. And yes, so that's everything from my side. I would give the microphone to Maria. Maybe you can also like give a short introduction to yourself. Emma, when it's your turn, you can also like give a few words about yourself. I think that's the better way. So yeah, thanks for having me. Thanks for having you here on our meetup. Hi, Maria.
Thank you, Max. Great to be here with everybody tonight. As I said, it's really good that we can do these meetups online, but it would be great to do that at some point also in person, and ideally perhaps in the combination of the two, so people from other countries can or other regions can join as well. I think this is what has been really nice, that we can, you know, just connect to anybody in the whole world. So during these meetups. So thanks a lot, Max, for inviting us. Really great to be here today also with Emma. So I'm just going to give you a really brief introduction to Fetch.ai, what we're doing, and then I'll let Emma do the keynote and really talk about the AI and blockchain, how we're doing that using CoLearn platform. So next slide, please. So I think that was basically the introduction, but let me just go back. I just want to say, you know, what I'm doing, and then Emma can talk about her role. So I'm Director of Business Development at Fetch.ai. We're working with partners in the industry, in academia, also with policymakers and regulators on, you know, bringing these new emerging technologies to the space to really work on real world industrial, you know, problems, solving them, helping us to move to the next century, and really trying to adapt these new technologies with all the various benefits that they can bring in. So that is my role here. And I work with, like I said, partners. So we'll see them on the next page, just a few of them. Next slide, please. Oh, this is, we'll skip this one, we'll go back to that. Right. So we have some really interesting German partners, Bosch, Festo, I think you are very familiar with them. We're also part of the Catena X project, which is a really interesting automotive industry project here in Germany. And it's spanning, several years going forward. And what we're really doing in that project is bringing these new technologies, like I said, to the real world applications, connecting them with the industrial partners, and really making these real world products. So let's go back. Sorry, Emma, let's go backwards. This one. So just a very short introduction to Fetch. So what we're looking at, actually a couple of different, major areas. I will talk to you about the one that is bringing agents, or we call them also digital twins, to life. And these agents can represent people, companies, and services, machines, for example, as well vehicles. And our mission is really to build this infrastructure that is required for these agents, for these digital twins, to organize complex tasks, which can then benefit individuals, businesses, and organizations. And we're connecting them with the blockchain to really, capitalize on the open source software tools, and then let anyone use and give access to the power of artificial intelligence. So next slide. Mention these. So we have here are some other partners that we work with, as I mentioned, in the spaces of regulators, policymakers, and also some universities are mentioned here. These are English, but we also work with several German universities as well. Next slide. So the digital twin platform, we're setting that up so anybody will be able to set up, hopefully very easily, these digital twins, these agents, just with a few clicks on the screen. So next slide. As I mentioned, these we used to call them agents, and we still call them agents, but people are much more familiar with the term digital twin. So we're now calling them both, and they really act on behalf of their owners to achieve goals, to achieve economic activity for the owner. These agents, these twins, are autonomous and goal-oriented. They're modular, so you can set them up to accomplish different tasks with the different modules. They're flexible and they respond dynamically to changing environment conditions. As I mentioned, they can represent various stakeholders, people, machines, IoT devices, organizations, services, data as well. So they have a really wide use. Next slide. What happens in real life situation is that every day these devices around us, IoT devices, companies generate more and more data, and a lot of that goes to waste. So we are giving this data, these organizations, this power through the agents to really connect to each other autonomously, to find each other based on the preferences of the users, to communicate together autonomously again, and really agree and exchange economic value, which is then entered also onto the blockchain. So these transactions are then trusted, verifiable on this immutable blockchain. Next slide, please. We have several examples here of the projects that we have worked on: decentralized delivery network, parking use cases, autonomous AI travel agents, and other agents or digital twins that can represent smart infrastructure, supply chain, smart marketplaces. As I mentioned, the real value is having real access to real-time information, to be able to analyze it, use intelligence and really analyze it, and really to provide dynamic adjustments. So I think this is really on a very high level, because today we're really going to focus on what Emma is leading, the area of collective learning, which is slightly different from the agents area, but it's related in a way that the agents, for example, vehicles, have a lot of data. And then what we really want to achieve is to really bring this data to life and bring it together from these different silos. And enable and improve machine learning on this data. So then it provides benefits to the organizations. So Emma, the floor is yours.
Great, thank you, Maria. I think that was a very good introduction to the broader picture of what Fetch does. I'm going to be talking a bit more about collective learning, which is our solution to using the blockchain to democratize machine learning, to enable people to use data sets that they couldn't otherwise have used. So as we said, I'm the lead of the collective learning team at Fetch.ai, yeah, very excited to share this with you today. Okay, so the agenda, I'll speak a little bit about what co-learn is, and then also say about what motivates us, so why we want to have this, about how collective learning or co-learn as we call it, lets you manage privacy, so protect the privacy of your data, and also show a little demo of the system as well. Okay, so what is collective learning? Well, we can use blockchain to decentralize the training of machine learning algorithms. And this means that the benefits of these machine learning models get shared across multiple owners of data. So what is an ML model? So these are ways of capturing the patterns from data in such a way that you can use the model then to make predictions. So an example might be like this picture we've got on the right, where we're using a model to analyze X-rays. Maybe you've got X-rays of people's chests and you want to say, do they have pneumonia or not? If you've got a labeled set of data, so you've got a load of slides of these X-rays, and you've got the labels that say these have pneumonia, these don't, you can use this to train your machine learning model and extract that pattern. And then you can use it to tell you in the future, it can automatically say, oh, that one's got pneumonia, that one's fine. And obviously this is very useful. You can do a lot of things automatically that previously you had to have a human in the loop for. And it's even better if we can use collective learning, because you can share the benefits of these models across multiple owners of data. And the data that we use to train these models is often stuff that's sensitive or has to be kept private. Collective learning means that we keep the data private. We don't have to share it, but we can still use it to train these models. Okay, so what is collective learning? It's a framework that lets us train these models on decentralized data sets. So this means that the data isn't all in one big database, owned by Amazon or Google or somewhere like that, but they're federated is the word we use, which means that it's split up into loads of different bits. So it's federated data sets, but in a privacy preserving way. So you're not having to, say, send that medical data up to the cloud, to some big cloud provider. You're keeping it locally and preserving the privacy of it. So no single party is in control of this training, because the training is coordinated by a smart contract. I'll come on to a few more details of that later. This means that the training is open, it's censorship resistant, it's transparent. You can see who has contributed to this model, exactly what their contributions were. And it allows us to monetize private data in a secure way. So previously you would have, you might have a very small amount of data that you couldn't have used by itself to make a model. But now using collective learning, you can still make a model and you can get rewards for that. Okay, so motivation for collective learning. So we want to achieve better machine learning model performance by collecting up those private siloed data sets. It said it's also a flexible monetization system. So people that connect their data up to these systems get rewards, which are configurable. Data models predictions. So yeah, it's rewards for the holders of the data. And so I'll talk a little bit later also about the holders of the models can get rewards for using them to make predictions. And it also lets people control and monitor the privacy of their data. So a little comparison with other ways of doing this. So local machine learning is when you just have a little small local data set. Maybe it's just your medical records, or maybe it's the sort of customer data from a small online shop. It does well with privacy because you don't have to share it anywhere, but you don't get as good a model out of it. And so the model isn't as good. You could centralize the machine learning, so put all of that data in the middle, but that's not so good with privacy. Also, it means that that centralized entity, which is some big corporation, gets all the profit from the model. Federated machine learning, so there's some techniques for sort of just adding together all of the updates that you'd want to give to the model. That's not very private because you're taking those data sets and you can work out what was in the data sets from the updates. And whoever's doing the centralizing, which is of some sort of central coordinating authority, is going to get the profit from it. So an example of this is those sort of speech models that you get on your phone. They're often trained using user data, so what you've written in your predictive text. But you're not getting any benefits from having your data used in something like that. It's the centralized, it's whoever's coordinating the training, which is probably your mobile phone manufacturer. Example here is like Siri, who's getting the benefit of that. So users aren't getting rewarded for providing their data. So collective learning does well on privacy because everybody's keeping their data private, but there's monetization, so users get the benefits of providing their data. And it's also decentralized, so there's one central model that gets owned by everybody rather than being owned by some big corporation. Okay, so privacy, I'll stress this again, so data stays local with its owner and the users can control and monitor their privacy settings. Okay, so some key benefits. Our data providers get to preserve their privacy. They also get rewards for collecting their data. The algorithms are improved because they have more data to work with, and all this feeds into improved business operations. So things like if you're in a manufacturing plant, you might have a model to predict when parts are going to fail. In healthcare, you'd have an improved model of disease and that kind of thing, which is the thing in the end that that the businesses care about. Okay, so I've talked a lot about the sort of in abstract why we want this, what the benefits are, but you're all interested in blockchain, so you're probably wondering like how does this actually work? How do you get a smart contract to do this kind of thing? So I'm going to show a little video here that demonstrates how this actually works. So okay, so we have a smart contract that coordinates the learning. Just going to. So we've got a bunch of participants here. They've all come along with their data. They want to collaborate together to train a machine learning model, and this is all coordinated by the smart contract. So what this smart contract does is it selects one participant to be the proposer. So we can see here our smart contract has selected a proposer. And then our proposer does some training. So like we said, a machine learning model is like a way of capturing the patterns in some data. So you've got your data and then you've got a sort of pattern that's being extracted here. And you send just the weights of your machine learning model around to the other participants. So you're not sending out your data, you're just sending this pattern that you've extracted from the data. So these weights get sent around to the other participants. They all evaluate them, so they see if this is an improvement to the shared model or whether it makes it worse, and then they vote whether it's better or worse. So here we can see that we got 2 positive votes and we got 1 negative vote. These votes go into the smart contract, and the smart contract tallies them up. We've got 66% yes, so that's a pass. And now we have a new best model selected by the system. And then training continues in rounds. No, next one. There we go. So training continues in rounds like that until you get to the point where the model isn't being improved by more training, or until you reach some predefined limits that everyone's decided on. Cool, right, so that's how you use a smart contract on the blockchain to coordinate training. The other thing that we all know that's very easy with the blockchain is to add these economic layers onto things. So, and you can use that to incentivize correct participation and also to reward people who do the right thing. So there's also tokenization in CoLearn. So users who want to participate stake some funds in order to join. If a user doesn't behave correctly, so this is if they fail to vote when they need to vote, or if they fail to propose when they're meant to propose, then their stake will be slashed. So they'll lose some of the tokens that they've staked in order to participate. So they get a certain time limit measured in number of blocks, during which they can submit their vote or their proposal. And if that's not received in that time, then they get slashed. And again, obviously, that's all completely transparent. You can see exactly what's happened because all of these transactions are recorded on the blockchain. So you don't have to worry about, you know, whoever's in control sort of maliciously deciding to steal everyone's tokens. Because it's all controlled by this smart contract, it's all publicly visible. You can see exactly what you'll lose and when if you don't participate correctly. And there's also rewards. Again, this is configurable. In some cases, you would just have everyone benefiting from the model. You wouldn't need a rewards pool. But in some cases, you've got one person who cares about the model and wants to fund it. So optionally, the leader can start the experiment with a pool of rewards, and then a user gets a reward if their proposal gets accepted. So we said the smart contract selects someone to propose a new update. If that gets accepted by everybody else, then they get a reward. And again, it's a smart contract, so this is all publicly visible. You know what you're going to get, and yeah, nobody can lie and not give you the tokens that they promised you. Okay, so now I'm going to show briefly just a little video of our system in action, so you can see it's actually a real thing, and it's got a nice user interface on it, so which makes it simpler to use. So people can, we see like some blockchain projects can be, if you're having to interact directly with a smart contract, that's a bit complex, but let me show this video. Cool, so let me play this. So here we're seeing our user interface. Here, just for a little bit of fun, I've claimed that this one's BMW. We're going to have another participant who is Bosch in inverted commas. Like I said, just put those on, not meaning to imply that they're liking it or using it, but just so we can see that there's two different participants. They're both starting out with some tokens, and they want to collaborate together to train a shared model. So they can set up their data, and this is their local data set. So here we've got one participant setting up their data set, and this is a local place where they've got some data, and also setting up a type of a model that they want to have trained in this experiment. So they both select the same kind of model, so their updates are compatible. Okay, and we're doing the same with our other participant. So Bosch here in inverted commas have also set up their data in their model. And now you can set up an experiment. So this is launching the smart contract that's got all of these parameters defined in it. So it's got who's allowed to participate, it's got what kind of model they're training, and it's also got those parameters for rewards and penalties all defined in there. Cool, so you've got to stake a bit to participate. There's a penalty if you don't participate correctly, and there's rewards if you do the right thing. BMW here is the leader, so they're funding the experiment, and so they've set an amount of reward that people get, and a fund of tokens to provide those rewards to people. Okay, and yes, also we're setting who's allowed to participate. So sometimes you'd have an open experiment where anyone can join. Sometimes you'd have one where it's closed. You just predefined a certain set of people that you want to take part. Okay, so our other participant here, which is Bosch, can join into this experiment. I'm going to skip forward a little bit so we can see the experiment in action. So we're joining the experiment with both participants together. So similar, so yeah, it's a similar step for both of them, staking in order to participate. And in a moment, we're going to be able to see the experiment actually running. So, so if we go to the dashboard, we can see here the experiment is running, so those rounds are completing. We can see here there's just 2 participants, but and it's only the one who hasn't proposed who does the voting. So we can see a graph of those votes coming in, and also performance of the model and how it's running. And also, if we go to our so this is both of them have this same dashboard, and also we can see that people are getting rewarded for submitting updates that get accepted. Cool, okay, so that's a little demo of the system in action. This is a separate aspect of collective learning that's under development. So the other thing that you want to do with a machine learning model is you want to use it to make those predictions and to be able to monetize it like that. So if you're somebody who comes along saying, I've got a load of medical scans and I want to classify them into like who's got pneumonia and who hasn't, then you might want to pay for predictions. And if you've got a model that does those predictions, you want to monetize your model. So you want to get a reward for having done all that training on it. So we also are in the process of developing a smart contract to enable people to do this on the blockchain. So our model owner can register a model that performs a particular task. Our user can pay for predictions, for example, identifying slides that have cancer in them. Our model owner gets to monetize their model, and the user gets the predictions that they want in a decentralized way. And everybody, again, it's public. You can see that it's in a smart contract, so you know what you're going to be charged. You can see that the tasks have been completed. Okay, so finally, just thought I'd stress again those applications. So collective learning really is good for any kind of case where you've got data that needs to be kept private, but you've got a strong need to make a machine learning model trained on that data. So medical data is a good one. Obviously, there's reasons why medical data has to be kept private. Also things like banking. So banks have data on fraudulent transactions. They can't share their account data, but they want to be able to detect fraud. Manufacturing data from production lines is often commercially sensitive, but you can use it to predict manufacturing failures. And really, there's many other scenarios where this is useful because you have that combination of stuff that you need to keep private, but also a need to create a machine learning model to extract those patterns from the data. Okay, so that's the end of my talk. Right, am I now switching over to, I think maybe Ricky is going to say a few words?
Yeah, before we step into the discussion, first, thank you, Emma. Thanks, Emma, for your nice keynote. It was really, really interesting, but also complex and intense. But maybe we can also, like, if someone else has some questions, step into them later. After we have all those informations, I just want to take the time and share my screen in order to show you a job offer by our sponsor for this blockchain meetup, 51 Nodes. So if you are a software developer in the blockchain space and you're interested in changing the world through Web3 technology and use your current experience as a software developer, then maybe this job offer could be for you as well. Or if you know someone who is a software developer and is looking for something interesting, there's also like the chance to receive some incentives, as well as if you are affiliating this job offer. And yeah, it's full-time or part-time. I will send you the link in a few seconds. Just to let you know, there are a lot of opportunities for you. And that's it from my side. Let's go into the discussion. And Ricky, maybe you can give also a short introduction for you.
Yes, of course. So first of all, also thank you, Emma. It was a great presentation. To myself, my name is Ricky. I'm currently working as a crypto economist at the Economy of Things research project at Bosch. I'm also part of the Central Financial Department, and therefore called a digital asset expert in the area of CBDCs, digital payment, tokenization. And besides this, I'm currently also working on my PhD at the University in Basel. And since almost 4 years, spending my time in the crypto space and researching in this field, and trying to contribute my 2 cents to this. And besides this, I take part in different expert groups in Germany related to blockchain and CBDCs, and also today as part of the team who is behind the blockchain meetup, which is blockLAB. I'm also a member of the blockLAB association. So this as a short background to myself. Yeah, so do we have any questions in here? I mean, it was great to see how Fetch can be used, and to see such a great application, which is in my opinion really important to lift the full potential of Web3 and ideally the economy of things, right? As we refer to this as a super modular digital society. Where agents take over and achieve their or reach out their full capability in such an environment, and therefore I think it's key to have data access and to be able to share your data in a trusted environment. And yeah, therefore I think this is yeah, a really interesting technology. And also a really interesting topic, right? If we combine artificial intelligence, machine learning, agents with distributed ledger technology.
Yeah, definitely. I guess like there's just one question from JJ, but also like if you're, for the other participants, if you have any questions, just write them into the chat group. Or if you just want to explain it a little bit short, then just raise your hands and you can say 1 or 2 sentences, ask your questions, but not so long. The time is for the speaker and the experts. But one question was like, could you explain the difference between your solution and Number AI or Numer AI? If you know what
yes.
or maybe just okay. If you can give a short introduction about Number AI.
So that project is, I think they call themselves the world's hardest data science competition. So what they're doing is they're a hedge fund who take financial data, they obfuscate it, and they pass it out to people. So they obscure the personal data in it, and then they give it out to people saying, come up with your own model on this. And we'll combine the models, we'll have a great hedge fund, and we'll give you some of the rewards. So collective learning is different from this because what participants here are bringing in is their own data sets. So for example, they're a set of hospitals with medical records, or they're banks with customer data, or even they're individuals with their own data sets. So it's more about making use of data that has to be kept private, rather than this sort of numerize, like as I understand it, at least it's sort of competition to come up with a better model on the data. So this is more about using data that would otherwise be siloed and unable to be used.
I hope that answers the question. Yes, Ricky, maybe you as an expert do you have a question, or do you want like to say something about the presentation, or I would just like ask some question of myself, if you like.
Like I said, I think like Fetch does a really great job in trying to lift those opportunities that arise from collective machine learning. And yeah, it's as I mentioned, it's great to see that the ideas of having a distributed ledger, using then agents, the co-learn part, implementing tokenized incentives or using tokens as an incentive mechanism to create an ad hoc mini economy, right, for data sharing and data learning. Is imminent and super important for the upcoming economy of things, where we call it. And yeah, therefore, like, this is my overview, I would say, on this. And yeah, so I would say I have no questions, since I'm aware of the of CoLearn and of the project itself. I pass the ball to the audience to get any questions, or Max, if you have something to ask for.
I mean, I have a few questions as well. Also, like because I mean, we were hearing a lot about the solutions, but still, it's also interesting. What are your current challenges still in developing? So, do you like have any barriers? Something else where it's like getting problematic?
It's a good question. Yes, obviously I'm a bit biased towards talking to all of the good bits and the challenges that we overcome. The difficulties in this sort of collective training, there's a few different ones. There's ones about people with very different data sets. So if somebody has just some sort of natural variety, that's good, but at some point the data gets too different. You can't use all of it to train one shared model. We have some ideas in this space to cluster people based on the similarity of their data. And that would, so you'd automatically, sort of people would be formed into these groups with similar data that's comparable enough to be able to make a model. So that's one of the challenges. So like I say, we've got some ideas to overcome this. As I mentioned, something we've got in development is this monetizing your model once it's been trained. So a marketplace for models and for data sets where you can, so this is something we're still working on building, but a marketplace where if you've got a model that's good at predicting things, you can go and people will pay you for those predictions. Or if you want predictions, you can go and pay to get some. And that's something we're working on at the moment, which will really be the sort of counterpart to this, because it provides it's a counterpart to the training side. You train the model, but why do you want to train the model? You train it because then it's valuable. You can monetize it then in the second step, which is that marketplace that I said that we're building.
Mm-hmm. And like maybe also like think about when we are thinking about the audience, or just like for a private person, why should they care?
So it's a good way of monetizing data. So instead of just, Siri or Apple or Google or whatever gets your data for free, you can monetize your data, which obviously everybody likes money, right? So that makes it very useful. And also we benefit from these machine learning models, from things like better models for predicting disease, or for predicting fraud. All these kind of models provide something that is so socially useful.
May I just add to that? So exactly, that's the point. So you may not care about like what some large corporation does, how they build these things, or how the industry uses that. But imagine that you are a private person, you go to a hospital, small hospital, they take an X-ray, but they don't have any specialists that can actually really evaluate that or give this extra boost that we can do now with shared with using additional AI capabilities on these data sets. So when and you're not able to, when you go to the small hospital, they're actually not allowed, even in most countries, to send this data outside. So how, you know, what do you do? So this way you can actually benefit, like personally, you know, I think everybody values their own health. So this is really the way how we think that, you know, perhaps the medical field in the future will be able to collaborate, right? So again, you know, the data must stay private. That's the highest, you know, that's the highest, you know, goal. But you still want to be able to evaluate that data, even if you don't have maybe your local specialists.
All right, nice.
Cool. I've just seen there's a question in the chat about the vote threshold. So I said that, yeah, an old model gets replaced by a better model if there's a simple majority. The voting threshold is configurable in the smart contract. So you could set a different threshold for sort of different scenarios. So you could say if you wanted to that you need a three-quarters majority to yeah, that bit's all configurable.
Thank you.
Okay, we've got another question. So how do we prevent people from stealing the models? So everything's encrypted is the short answer. So our participants join into the experiment by submitting a public key. The model weights are encrypted using those public keys. So only the participants who've registered can decrypt them using their private keys that they store locally. So yeah, it's publicly, the hash of the weights is stored inside the smart contract, and the weights themselves are stored on IPFS, because as we know, blockchain storage very expensive. So using a public distributed file system, you store the encrypted weights, and then all the participants are able to download them and decrypt them with their private key.
Okay. There were also like a few questions we stepped over. Like one question was also, how is the Fetch.ai collective learning offering different from your machine learning offering?
I think this might be about what we've called it in different scenarios. This is our offering for machine learning. Yeah, it's so collective learning is how we sort of solve these machine learning problems.
So collective learning is using machine learning, but collective meaning like collaborative learning among various participants.
Yeah.
I mean, that's put it easy. Like, so collective learning is just like using the functionalities of machine learning. Yeah. There was also another question about Bosch and Fetch. Could you already elaborate or show some insights on the current status of the machine learning traits between Bosch and Fetch?
I just would like to stay away from that. So what has been published is available. I just want to say, you know, we are both of these companies, us and Bosch and many others are participating in Catena-X, as I mentioned earlier today. All the partners in that association are publicly available on the Catena-X website. And I just want to say that, you know, one of the areas that the project is looking at is privacy preserving technologies, which, you know, CoLearn belongs to that category. And I think what's important to note is that, you know, there will always be different use cases that require different privacy preserving technologies, right? So this isn't applicable on everything, but, you know, some people are happy to just, or some maybe organizations could be happy just to share the data in a very simple way. And others, you know, on the contrary, will really require high level of privacy on their data. And for those examples and use cases, you know, we have the CoLearn available. So there is a really big range of, you know, what is out there, what kind of technologies can serve the individual use cases.
What kind of applications exactly? And just to add here, the ones who asked the question, I mean, we have a research blog out from our Economy of Things research team, and there are all the public available information. And of course, as Maria said, we cannot talk about project internas, Nevertheless, what we tried to identify there was the potential failures of the manufacturing machinery, and therefore we would like to utilize the co-learn algorithms and shared data sets to improve those potential failures.
Nice, thank you. Also another question by Thibaut Wheels. I saw the co-learn X-ray COVID-19 recognition. Will this technology be expanded to other pathologies, or was this rather an example to show that co-learn can be beneficial?
It was really to show that it was beneficial. Sorry, Emma, I'll let you talk about the details, but this can be expanded to anything. It's really about the improvements in AI, whether it's on X-rays, you know, for COVID, or X-rays for cancer, or anything else. I mean, we have done some other interesting project, and Emma can talk about it, with Polish researchers. This was, I think, around. Yeah, Emma, please. I'll let you.
Yes, so the COVID-19 one was an example to show so collective learning being used. It's a sort of a topical example showing why this is useful. Collective learning can be used wherever we've got data sets that need to be private that you could use to train a machine learning algorithm on. So wherever machine learning is good for, like I said, all those sort of all those different sort of applications, like in a manufacturing plant, detecting failures, detecting diseases from scans. It's not limited to that one example. That was just a way of demonstrating why the technology is useful.
I see. Another question by Sebastian: how could you facility management provide data and models to benefit from collective learning as a whole industry?
So if you, sorry, Ricky, do you want to go ahead?
No, I just have an example, but you can go first, of course.
So if you're a data owner, you can run your own collective learning node, and this provides the interface that we saw in the demo video, and it means that you're keeping your data locally, but you can still participate in these experiments. So that's how you would use it.
And and regarding facility management, I think it's if you have a look on the energy usage that those buildings have, right? You have a lot of energy usage, conditioning, lighting, everything that belongs to facilities, so to say. So I think that would be also a great field of where you could use machine learning, co-learn algos for heating, for energy. Energy-based things, and try to improve your efficiency and lower your costs. Indeed.
I mean, like this is one example, the facility management you already mentioned. Also, other examples as an application. Are there any other ideas or industries you could tackle?
Probably a good one for Maria
Sports.
there, I think.
What about sports?
Sports, I'm not sure about sports. Like it depends. Like what is the privacy concern in sports? I think that's what you need to ask yourself. Like, do you care to share the data? Do you care what, you know, do you want to let people know what you're betting on? If you don't, then, you know, that's your privacy concern. That's when you would use co-learn. If you don't mind your data being shared, you know, then you probably don't need to use co-learn. But this is really, like, I think we haven't really talked about banking much, but this is really good in terms of like banking, because similar to say the the healthcare industry, also banks are not allowed to share data, and maybe not even move them from one office to another. And so this is the way for them to then even internally, so you don't even have to have an outsider who wants to, you know, improve an algorithm, but bank, by connecting its different offices within a country, is able to then improve their own machine learning and AI algorithms and capabilities, right? And to learn more about, say, its users. So it doesn't necessarily have to be a connection between different parties or many participants from different environments. It can be within the same bank or within the same, say, other company that has different branches that are not allowed or not able to send out the data outside of their office.
Super example. And I think you can
and in that case, actually, I just wanted to continue. In that case, what you can also think about doing is actually to have a fully private environment. So we have an enterprise solution where you can even set up like a private blockchain that is outside. It's still using the blockchain principles, but that way it's completely, siloed or this, not visible to the, to the, say, open public blockchain ecosystem. So there are different variation, different ways we can play with that. Also, there are some additional privacy features that we are working on. We haven't discussed here, so there is a really different way to calibrate this system based on the privacy requirements. I think that's the key to think about that. How private do you want or do you need to have your data? How much can you share? How much can you not share? And then it's then you can set up the system.
And to add here, I think you could even go further, and I think it will be hard to find a segment or specific field where you cannot use like machine learning or co-learning to improve your strategy or anything that belongs to your business. So I think the space, if we really think of the future, how it will be and how data will be collected, and even regarding to sports, right? So whenever you go on a defense or an offensive tactic, and you have available data sets over the past history of your components or whatever, that might make sense to have machine learning to find opportunities to improve your game. And therefore, I think there will be. It's hard to find those spheres and branches where you do not make use of machine learning or co-learning in the future, right?
I just want to answer, there's another interesting question. Can agents, digital twins, be programmed to autonomously supply certain specific data sets to your machine learning platform? Absolutely. This is exactly the vision that we're working towards, that your agents, your digital twins will understand your behaviors, will have actually information about your own data. And then they act, then they can find other agents that want to collaborate on this, either within your company or others as well, and build these algorithms together. So this is really the cool thing, because there's so much data really out there that is available and that is not being used. So how can we make a better use of it and make everybody's life simpler and easier, really? So absolutely, that's where we want to see things go. You can think of that, maybe like having a digital twin of your car, and that car is talking to another car, negotiating not only your parking space, so that was the use case we showed in September when we were in Munich, but actually then using that data, maybe the data about the brakes, and then say, hey, look, when I go this speed, the brakes are better, performing, or I don't know, many various examples. I don't want to go into the details, so but I'm just making this up at the moment. But think of that really, other kinds of data sources from IoT devices, from cameras, or for something from somewhere else where you want to really keep the privacy on the highest level, but want to be able to share this. That's when you would apply that, and then the agents would can do that communication, can reach out to other agents autonomously while you're doing other things, going and doing your sports. Max.
Yeah, hopefully sometime it's going to sports as well. It's like my main topic, but I was also like thinking about as another example, like how is it Tesla currently doing, because I'm not sure like if they use something like co-learning, but they also like have so much data and also use machine learning or AI in order to see objects and to identify them is it also possible to include it there, or why is not Tesla using it?
I don't know. We haven't really, you know, these are the things that we're not able to discuss all of that, but everybody, I think every automaker has their own ways how they do things and how they want to collaborate or not, right? And so Tesla is a centralized company, so they have access to all their data, and how they use it, I think we don't really know. So it would be just a speculation, I think, on our part, just to say anything. So I think we stay out of that.
But could it in future in general be difficult to compare, to compete with all those centralized platforms like Tesla, Facebook, Google?
I think we all understand what's going on and where the centralized platforms are taking our privacy, right? I mean, there have been so many examples of breaches of privacy. So again, I think the more and more we hear about that, and the more we, you know, use our I don't know, private data for banking or for healthcare, then I think at some point we'll all see that there's only so much, you know, a limit on what we're accepting to use, and how much private data we really want them to know or have about us, and then people will, I think, the more education also is brought about blockchain and how these new solutions can actually tackle these issues. I think the combination of these two, the education about the issues, but also education about the possibilities that are out there, how we can change and do things differently, and having these options, I think then it will show, and people will be able to make these decisions. I think if you look at what happened with, I think WhatsApp what was that, a few months ago, when WhatsApp announced that now they're under Facebook and it's Facebook rules apply and data is going to be collected about WhatsApp users, so many millions of people went and started using Signal or other, you know, other private platforms. So I think once you have those options that you can use more privacy preserving technologies like CoLearn and others, and when they're made available, then people will definitely explore them, and then it's about adaption.
I mean, there is a bit of a performance hit using collective learning versus just centralizing all the data. But what those big centralized companies have is regulatory risk. I think at some point we're going to see a lot more regulations saying that they can't keep using the data for what they're doing. And at that point, distributed solutions like this will still be able to continue. And that's
actually the point of the next person's comments, that the European Commission is actually looking at that as well. So that's absolutely true. And I actually have to say, I'm really glad that we're in Europe and our regulators are really paying attention to this and looking after that. So yeah.
Nice, thanks for all the answers. There's also like another question by Mark who is asking if the CoLearn is applicable on every machine learning model.
So it's applicable on all kinds of models where we can have this incremental training, and so each person can do a little bit of training of their own. So we've used it with neural networks a lot, because that's how you train a neural network. You do repeated iterations of training with your data, and gradually the model gets better and better. We've also used it with a slightly modified version of random forest, which is another kind of algorithm. If you have the kind of algorithm where, you know, something like, I guess, fitting a straight line through data points, where you literally just write down the solution, there's no kind of iterative process, then collective learning wouldn't apply for that. You need that sort of iterative training. But then, I mean, putting a straight line through some data points is very, very simple, and probably you wouldn't be using something like that anyway. You'd be using a more complex model like a neural network or a random forest or something like that.
Maybe a more like general, I remember, is it like you use a public blockchain, but could also, like, some companies could use a private blockchain as well, so it's siloed. But what are which blockchain is it actually, or which consensus mechanism are behind that?
Everything we're using is running on our test net, which is a Cosmos-based blockchain. So Cosmos They have a sort of technology that underpins a lot of blockchains, which means that it's nice and interoperable with other ones. So the smart contract we've written is all in Rust, and it can be used across other Cosmos blockchains as well. So if a company wanted to have their own private blockchain for some reason, or some group of people wanted a private blockchain, that would also work, be a Cosmos-based blockchain with a smart contracts in Rust. The idea could be ported to any kind of blockchain technology. You could do it in Ethereum instead, but what we focused on is our testnet, which is a Cosmos blockchain.
Mm-hmm. And I guess like we heard, I guess we heard a lot of examples. I'll have a look if there are any more questions. I guess not. Do I have some more questions? I mean, like one general question in the blockchain space is, as always, how you solve the Oracle issues when some real information are coming into the blockchain world. Are there any identifiers for?
So we actually have an interesting solution. Our agents are can be set up as oracles. So we're working on that. We have already done that a few months ago, and then went on to do other things. But yeah, the agents have such really good capabilities and modularity that they can serve that purpose as well. And then that makes it actually really interesting because they are adaptable in real time as well. So and more intelligent than just some simple data points on the blockchain. So definitely that whole ecosystem that we're building with agents, with the ledger and with the co-learn works really well together on all these different use cases.
Mm-hmm. And regarding to those digital agents or twins, like what is their, or what is the role of a digital identity? Is it kind of a digital identity, or?
So agents or twins, are able to have their own digital identity. We have done that with SSI in the proof of concept in that demonstration in Munich in September. So we were actually using the ID union, but we're building also our own solution on the Fetch blockchain. There are other ways, so it really depends like what the preferences are, but yeah, the aim is really for the agents to really have their own representation, their own identity, and then they can really do many things autonomously on behalf of their user.
Mm-hmm. Okay. And also, like, I guess it's also a question to the digital twins. Is the convergence with your digital twin already ready for automation?
Yes, so we're hoping to give you some more information on that towards the end of Q1, and definitely in Q2 this year. And what we're looking to do is really to open it up, and so to have you guys try it out. We want to get it to the state where you don't have to spend days or weeks programming it, but so the platform is so easy that you can put together your agent quickly. We're working on some hackathons around that in the future, where you can build these agents and give them different capabilities, different modules, and then also at some point later then in the future then connect them with co-learn and bring all of this together through different hackathons that we're preparing in the space of mobility, but also supply chain and others. So yeah, stay tuned. Email us at info@fetch.ai. Or just watch the space, really. I mean, there's a lot of info coming out on Twitter. And when we're ready to talk about it more, we will definitely let you know.
Nice, thank you very much. I mean, Andreas was also like asking if it's scalable then?
Yes, and this is also the reason for choosing, the Cosmos SDK and building our own variation of that. So it's aimed towards scalability, so we can support machine-to-machine economy, where you don't have these really big fees and for the transactions like you have on some other blockchains that are currently out there. So it's all going in that direction.
All right. Okay, thanks. When I have a look at the time, and we also want to try the networking session, I'm just asking like one more question to all of you, experts and speaker. It's how do you, or what is your outlook for the future? Maybe when we look at 3 to 5 years, what are your expectations, or how will the whole space develop? What is your prediction? Maria, maybe you can start if you want.
I just hope that really these technologies that we're discussing will be deployed in and really helping us solve real world problems and real, you know, so we're not here just for, you know, for crypto to crypto, you know, projects, but we're really working on real world problems that are connected to, you know, machines, to vehicles, to other things that you can touch already now, but we're just adding that additional, you know, technology layer on top of that, and really trying to bring that all to life. And what I want to say is that, you know, maybe some people think it's too futuristic, but if you think about that, you know, 5-7 years ago, we were using our watches just to measure time, and look what they're doing now, right? So they're measuring our steps, heartbeats, anything. So you can think of them as in the future being maybe your health agent, where then these can then communicate directly to your doctor and say, oh, look, you know, somebody's heart is not okay, you know, the person will need to, you know, be brought to surgery or something, right? And so in a similar way, we should think about machines, about vehicles. Machines can be connecting together and really helping us to solve our problems much more quickly and autonomously.
Nice, thank you.
Yeah, what I think is interesting for the next few years, also the interesting thing about blockchain is that it can solve these coordination problems. So previously you'd have people who benefit from working together, but they can't overcome sort of barriers of trust or making an agreement between themselves. And blockchain's here to stay now, really. It's increasingly being adopted in other places. And I think that's what we'll see a lot more of, is blockchain solving problems that we probably haven't even thought of yet, but overcoming those coordination problems by enabling these trustless solutions.
Thank you, Ricky.
And I would just agree on what both of my first speakers said. So I really think that blockchain technology and also the things that we have heard today will lead the digital economy to efficiency, solve the coordination problem, solve the privacy problem, and also what you pointed out, Max, that we're able to compete with those current platform giants, with those monopolists, and that we're able to build a future that is more built on privacy. And yeah, so overall having to like I said, raise digital efficiency, raise privacy, and in the context of of being beneficial for every one of us. Like, so as Maria said, to use the technology or your force yourself, instead of being just a sole data provider for corporates that currently have a high information asymmetry and a high power disbalance in the game. And I think therefore blockchain technology will be used to leverage this to create more fairness, and ideally also create a more democratized web, which we refer as Web3, right?
Right. Yeah, thank you very much, Ricky, also for your input. And yeah, so I would say like this would be the end of the discussion part.